morning, children. This is 12th Physics, Chapter 3, Current Electricity. In this video, we will cover the topic current density J, which is the vector quantity, mobility of charge carriers mu, and finally we will derive the relation between the drift velocity Vt and the current I. So let's start with the current density. So current density means the amount of charge that is flowing through a particular area per second, and provided the area is normal to the direction of flow of charge. For example, here this is a conductor which I am drawing, right? This is a wire which I have zoomed it. Now inside this wire I am taking this small cross section. I have selected a very small cross section inside the conductor, right? Now as you can see, this cross section is perpendicular to the direction of the current. The direction of the current and your cross section which we have selected, right? This one this is in this direction, right children, and your current is in this direction from left to right, and the area of the cross section, they both are, as you can see, the area of cross section is like this and the direction of current is like this. So the cross section and the current, they both are at 90 degree to each other. They both are at 90 degree to each other. So current density is the amount of the number of charges which are going to flow through this area per second, and this area should be normal. The area should be at 90 degree to the direction of flow of charges, right? So through this cross section, suppose I name the cross section as P. So through cross section P, the amount of charges, right? The amount of charges that are flowing per second is called the current density, right? This was the case when the cross section and the direction of the current, they are 90 degree, they are perpendicular. So the current density will be given by J, and J, as we said, it is charge flowing per unit time upon area. So J equals to I by A. J equals to I by A, right? Here A is the area of the cross section through which we are calculating the current. So for that area, for that cross section, this would be the current density. This would be the current density. So current density is a vector quantity and its direction is along the direction of your current. Its direction will be along the direction of your current, right children? Now here, as we saw, that the area, cross sectional area, that was P, that was perpendicular. Now I am selecting a different cross section. These are possible, right, inside the conductor. Suppose I name this cross section as Q. This is inside the wire, cross section Q. Now as you can see clearly children, as you can see here, the cross section, initially the cross section P was like this and the direction of current was like this. So they both were making an angle of 90 degree. But now the cross section is like this. The cross section is not making an angle of 90 degree with the current. Now what is to be done, right? So children, now we are going to draw the area vector. We will be drawing the area vector through this cross section. So this was the cross section which we had selected, and let it be called Q. Now this would be the area vector. As we know, area is a vector quantity. So this is the area vector. This is the unit area vector that is perpendicular to the surface, right? This here A is the vector that is perpendicular to the surface. So this is my area vector and this is my surface. Surface is tilted like this, right children? So this is my area vector, right? This is the tilted cross section, that is Q, and this would be the area vector for Q. Right children? Now this area is a vector quantity. So we can resolve the area vector A into two components. So this is my component that is along the x-axis, that is A cos theta. Suppose the angle is theta, right? Between your x-axis and your area vector. Similarly, we know there would be a y component and that would be A sine theta. The y component would be A sine theta. Now, it is but obvious from the resolution that the component that we are going to select should be such, the component should be such that it is along the direction of the current. The component of your area should be such that it is along the direction of the current. So here we can see the two components. One is A cos theta and other component is A sin theta. Now we are going to talk about A cos theta because A cos theta is the component which will be along the direction of the current, which will be along the direction of the current, right? Initially also when we saw that the cross section was perpendicular to the current. So for that the area vector would be this. This is your area vector when your cross section was perpendicular to the current and current direction is also along the area vector. So in that case also we saw that we are considering area vector that is along the current. So here as the area vector is not in the direction of the current, so we are resolving it into two components. One is A cos theta and other is A sin theta. So we are going to consider the A cos theta component which is along the direction of current for finding the current density. Right children? So we are going to have J equals to, we are going to have J equals to I upon AN, I by AN, and here AN is the component of area vector along the direction of current, along the direction of current. Now we know along the direction of current is A cos theta, so we are putting that is J equals to I upon A cos theta, and if we make I subject of formula, this will go in multiplication with J, so it will become I equals to JA cos theta, and as it is cos, it will be shown by a dot product. So I equals to J dot A. I equals to J dot A, right? So here you can see that your electric current I, that is a scalar quantity, that is given by the dot products of two vector quantities. Now let's talk about the unit of J. Now as we know, J equals to I by A. So we are aware of the unit of current, that is ampere, and the unit of area is meter square. So the SI unit of J is ampere m raised to minus 2. Ampere m raised to minus 2. Right children? This is your I, this is your SI unit of current density J. Right? Now, Let's move to the next topic. I hope this is clear. Next is your mobility of charge carriers. Mobility of your charge carriers, right children? So mobility, we know mobility is with motion, that is with movement, right? So in electrical charges, we are aware that in conductor, it is it are electrons those who are moving, right? So with what ease they are moving, right? So mobility. Suppose we are having a conductor over here. So I am drawing a conductor here. This conductor I am connecting it to a battery, and suppose the battery is of 10 volt, right? Now we know because of this positive negative here, positive and negative, the electric field will be developed from positive to negative, and the electrons which are present inside the conductor, the free electrons, they will be drifted towards the positive side, right? Now we have connected 10-volt battery, right? This was the case. Now suppose I am replacing the battery by 100-volt battery, 100-volt battery. So now you will see the drift that occurs in the electrons is very high. So as your electric field is increasing, as you are increasing your potential 10 volt से 100 volt कर दिया, so as your electric field is increasing, the drift velocity with which the electrons are drifted towards the positive end, that also increases. So we can say that your drift velocity is directly proportional to electric field. Your drift velocity is directly proportional to electric field. So if we remove the proportional sign, your constant will appear, and your constant is mu. So mu is the proportionality constant, and it is named as mobility of electron, and it is named as mobility of electron. And if we make mu subject of formula, then we will have this E will go down, that is Vd by E. Vd by E, right? Now let us see the unit of mu. So if we are talking about SI unit of mu, then it is velocity unit is meter per second, because Vd is what? That is drift velocity, right? Electric field, we know the unit is volt per meter, volt per meter. So the unit of mu, that is mobility, becomes meter square per volt second, meter square per volt second, right children? This is the unit of mu, that is meter square per volt per second, right children? Now suppose we need to define mobility. If we want to define mobility, now mobility is Vd by E. Now if I say that my electric field, if I make the electric field, that is volt per meter, right, as 1, if I make my electric field as 1, as unit, right, then mu mobility will be equal to the drift velocity. So your mobility can be defined in terms of drift velocity. That is, the mobility of a charge carriers is the drift velocity acquired when the electric field is unit. When the electric field is unit, means if your electric field is unit, at that time the drift velocity with which the electrons are going to move, that gives you mobility, right children? Chalo. Now let's start with the, okay, here you're having a small relation between current and your mobility. So current and mobility, we have derived this equation, I equals to NE, I equals to NEAVT. We know the terms here. N is the current density, N is the, sorry, here N is the electron density. N is the electron density. E is the charge of the electron, that is 1.6 into 10 to the power minus 19 coulomb. Right children? A is your area of the cross section of the conductor, and V is your drift velocity. Right children? Now what we need to do, now here we need to derive the relation between I, current I, and mobility mu. Now we know mobility is what? Mobility is mu. Mu equals to what? Vd by E. So here we can see VD, here it is. So what we will do, we will divide by E on both the sides. So if we divide by E on both the sides, we are going to get is, this can be replaced by mu. So your I by E equals to N E A mu, right? Now E can go on that side. So I equals to N E A capital E mu. So this is the relation between current I and mobility mu. This is the relation between current I and mobility mu, right? You can see it over here. Now, the last topic of this video, and that is relation between drift velocity and electric current. Very important, very easy. Now, children, we are going to derive the relation between current and drift velocity, right? So, for current, we know current I equals to Q by T. I equals to Q by T, right? So, for finding I, we need to know the amount of charge in the given conductor. आपको जो conductor दिया है उसमें कितना charge है, right? And secondly, we need to know the time. That is the time taken by the charge to move through the distance, right? So we will find charge, we will find time, and then we will substitute the values in this formula I equals to Q by T, and then we are going to get the relation between the derived drift velocity and the electric current, right? Let's start. So here we are considering, here you can see this is a conductor, right? The conductor is connected to a battery that is of V volt. Now this V volt battery is going to produce electric field from positive to negative. So you can see the electric field is produced, and because of this electric field, the electrons, free electrons which are present inside the conductor, they will experience a force that is F equals to minus EE, right? इतना force लगेगा, और because of this force they are going to be drifted towards the positive side, right? Okay. Now the area of the conductor, area of cross section is A, length is L, length of the conductor is L, right? Now if I want to know the volume, what would be the volume of the conductor? Volume will be A into L. This is the volume of the conductor, right? This is the volume of the conductor. Now be very attentive, children. What I am doing is I am choosing a very small volume of the conductor, and this volume I will say it is a unit volume, means 1 centimeter cube. Okay, जिसकी लेंथ भी 1 सेंटीमीटर है, ब्रेथ भी 1 सेंटीमीटर, हाइट भी 1 सेंटीमीटर, तो उसका वॉल्यूम कितना हो जाएगा 1 सेंटीमीटर क्यूब. So in this 1 centimeter cube, we are supposing that there are n number of electrons. How many electrons? N electrons हैं. कहाँ पे? In unit volume. Unit is 1, right? In unit volume, there are n number of electrons. So in unit volume means in 1 centimeter cube volume, how many electrons? N electrons. Total volume कितना है बेटा? ये रहा ना, अभी हमने किया. So total volume is AL. तो AL में कितने electrons हैं? Simple cross multiplication, AL into N. So how many electrons are present in the total volume of the conductor? Total volume क्या है? AL. तो AL में कितने electrons present है बेटा? NaL. So NaL gives you the total number of free electrons present in the conductor with area A, length L, that is volume Al. ठीक है, ये तो इलेक्ट्रॉन्स हो गए. ठीक है, इतने इलेक्ट्रॉन्स हैं. हमें पता है 1 इलेक्ट्रॉन का जो चार्ज होता है that is 1.6, rather 1 electron, the charge on electron is E. हमें पता है, ठीक है, 1 इलेक्ट्रॉन का चार्ज कितना होता है? E. E की वैल्यू वी नो 1.6 into 10 to the power minus 19 कूलम. How many electrons are there? हमारे पास कितने इलेक्ट्रॉन्स है? ये रहा, अभी तो कैलकुलेट किया हमने, राइट? That is NaL. So total NaL electrons, what is the charge? Charge on one electron E 1.6 into 10 to the power minus 19. So total कितने electrons है हमारे पास? NaL. So what would be the total charge? So simple cross multiplication. That is NaLe. This is the total charge which is present inside the conductor whose volume is Al. The total charge Q, देखो बेटा हमने Q find कर लिया. Now we require to find out T, time. Q हो गया, T find करेंगे and then we will substitute the value of T. Right children? Now for T what do we require? We know that velocity, uh, your speed equals to distance. Your speed equals to distance by time. Right? If I make time subject of formula, t will go here, v will come down. So we will have t equals to d by v, right? Now, time is t. Distance, what distance your current charge is going to travel? Distance kitna hai? Length jitna. So we will substitute instead of d, we will replace it with l, right? So, and with for velocity, we are replacing it with drift velocity Vd. So this is my formula for time. T equals to L by Vd, where L is the distance that the electron has to travel. And L is what? Length of conductor. Electrons जो है वो length of conductor से travel कर रहे हैं. So we have replaced distance by L and velocity with drift velocity. So this is my equation number 2. That is equation for the time. Now we are substituting equation 1 and 2 in the equation, in the very well known equation I equals to Q by T. So let us put this value over here. Let's see what we will get. I equals to Q. Q is NaLe upon T. T is L by Vd. So we know LL will get cancelled. I equals to NaEVD. NaEVD. Right children? So this is the relation between the drift velocity and the electric current. Right? Now, suppose I don't want your current. I want, this is one equation, right? Let's turn the page. Okay. This is one equation. Fine. This gives the relation between current and drift velocity. Okay. Now, if I don't want current, I want current density. So, we know the formula of current density. J equals to what? I by A hota hai na? So, what we will do? We will simply divide the equation by, we'll simply divide the equation by A. Just a second. We will divide the equation by A on both the sides. Here A will get cancelled. So what is left? What is left is NEVD because A got cancelled. Let me show it again. This is the equation. We will divide it by A on both the sides. On dividing by A, we will get I by A is J, and here A will get cancelled, and we are left with NEVD. So this equation gives the relation between drift velocity and current density J. Right? नेक्स्ट वी हैव स्टडीड मोबिलिटी ऑल्सो टुडे. सो अगर हम बोलें कि भाई हमें इसमें मोबिलिटी के टर्म्स में चाहिए ये वाली इक्वेशन इन टर्म्स ऑफ मोबिलिटी, वी रिमेंबर मोबिलिटी इज व्हाट? ड्रिफ्ट वेलोसिटी अपॉन इलेक्ट्रिक फील्ड ई. सो इसमें ड्रिफ्ट वेलोसिटी तो ये रहा, तो इसको डिवाइड बाई ई कर दें. चलो, सो विल डिवाइड ऑन बोथ द साइड्स. So dividing on both the sides, this Vd by E is what? Here we will get I by E equals to NaE mu. And if we make I subject of formula, this E will go to the other side, right? So you are having now NaE mu E. So this equation gives you the relation between the electric current and your mobility. So children, today we have covered these topics and I hope they are clear, right? Okay children, we'll end the class here. Bye children, take care.